I'm pleased to introduce the authors. The paper they're presenting is called Exploring the Excited Skin, Gigapixel Imaging of Soil Profiles and Landscape Contexts. The people we have here joining us for this, one of them is a returning Fine Fellow, Ken Tamminga. He's a professor of landscape architecture and is on the faculty of the Graduate Ecology Program at Penn State University. The other two gentlemen we have with us, we have Rick Stehouwer, who is professor of soil science at Penn State University, and Patrick Drohan, who is also a professor of soil science at Penn State University. So please welcome the three of them to make a presentation on the excited skin.
Thank you, Illa. Well, that was a hard act to follow and a beautiful act to follow. And we think that we're about to present something that's equally beautiful, called the excited skin, which my soil scientist colleagues get all excited about. I know it as dirt, they call it soil. Well, our premise is that gigapixel imaging, in concert with the Gigapan website, can facilitate soil science learning and research, and that these technologies can help bridge learning divides and disciplinary isolation between soil science and allied fields, and you can take it as far as you will. We're finding that these tools are highly useful in democratizing and accessing understanding of the Earth's excited skin, to quote Russian soil scientist C.C. Nikiforov. And as we'll discuss, these tools can do so in several interactive ways. First, through high-resolution images of soil profiles and nested detail, through enabling tagging and linkages of contextual gigapixel images and relevant data and information at multiple scales and as underlying or overlying layers. Talk about that in a minute. And in doing so, mediating a virtual forum of disciplinary perspectives and exploration, whether focused and in-depth or generalist and integrative. Here we are. We come from several different spots on the Penn State campus. Friends who started sharing the Gigapan stories and said, hey, I wonder if it's interesting, it would be interesting to point the camera at a soil profile. Can anything be less mundane? Well, the more we did it, the more we realized this is pretty interesting. Thanks for funding and support from these organizations. Basically, I'll just briefly touch on gigapanning itself in the field, in the soil profiles, talk a little bit about the all-importance of cascading scales, nested systems, and interdisciplinarity. Rick will talk about soil science learning, and Patrick will talk about a little bit more about soil science learning and soil science research. So here we are, stuck in, I think this is the Hagerstown soil pit on the experimental farm at Penn State University, getting a feel for how close, how far we can get, the shape of the pits, the technology we used. We have the Gigapan Epic 100, lovely little machine. Highly recommend them. I'm not being paid to say that. A Canon PowerShot, the SX10. Again, a nice little camera. It really zooms in far. Rick has the Canon EOS Rebel T1i that we're getting much more comfortable with. And of course, we use the latest Gigapan stitch and upload software. Some of the things that we do to get our images, and we're really starting to roll along now, and Rick will talk about hopefully setting up a library or a gallery through the gigapan.org website. Fields of view, you can be closer or farther. Our Stitcher information says we're at about 3 to 5 degrees at the closest. Then we get a small slice of a pan or a cross-section in these pits, out to about 10 to 15 degrees if you want more context and more opportunity for serendipity. One of the shots has a biopore with a little millipede hanging out going, where am I? You know, just kind of stuck out there in the open. And so we see soil, flora, and fauna happening the wider we swing back, but we lose a little bit of detail. Lighting, bright but not harsh. Side lighting is good to some extent, about 45 degrees or so, whatever you can get. Like to stop down the aperture and watch out for blurring. Some of the things we'd like to tinker with as we go along, and we'd love to share stories with anybody else that does this sort of thing. Add field lights, because the lighting will vary. Sometimes the sun gets too harsh. Perhaps add a 2x teleconverter. Focus stacking has been discussed yesterday at the FOFS workshop, and that's really exciting, so I stuck that in there. Focus stacking and Photoshop processing with maybe smaller sections could be a lot of fun. Custom dug soil pits, we shot flat profiles, but what about shooting curved profiles that match the curvature of the focal plane of the camera? And then linking to Helikite, we have another project called low elevation aerial photography. Get the camera up there shooting the context, the landscape context, ecosystems, and land use context of soils that really set up indirectly and directly what's happening on the Earth's surface. And here, for instance, is an example of the Helikite that we use around campus on some of the student projects. So that can be mined. There's a lot more things that can happen there. Just a little concept map. The soils, the orange line there is where we start. We think about soils as being generated from geology and landform, of course other determinants as well, climate and so on. And soils then express themselves in ecosystems and landscapes and land use patterns. It's quite a direct relationship. If we take it to the right, the soil profiles can be captured with Gigapan images, and along with soil information that can be tagged, uploaded to the Gigapan website, we can do the same thing with related information on geology, landform, ecosystems, landscapes, land use. You can go on and on, all cleared through the Gigapan website. And then we see this wonderful sort of rich mediation of information and knowledge sources. So this is ideal, right? Take students out into the field or interdisciplinary research teams, get a sense of geology, physiography, landform, and then we start to understand how soils are formed and created. We can take our models into the field, but we are also starting to think about, what about taking Gigapan via the iPad back out into the field and accessing information that's not field available, such as geological cross-sections. Here we are side by side. This is where we, as a team, really start to sort of jive, where myself and my students are looking at vegetation communities, landscape features, and the soil scientists are in the pit teaching our students and their students about the interrelationship between soils and vegetation communities. Very exciting. And of course, this landscape would not be what it is without this wonderful, rich, calcareous, fertile soil called, in this case, Hagerstown soil. We've split this sort of realms of knowledge and information linkage into sort of in situ representation. This is on some of the soil pans, you'll see this sort of information stacked below the Gigapan, and it's also in the paper that comes out from the conference proceedings. The generative context, geology, mapping, cross-section, Gigapans elsewhere from some nearby road cross-sections, and expressive context. So we're on-site and we take panoramas, and we also can then link to plant community data online. And it's all there in the Gigapan website. We're looking forward to the updated version of the ability to do galleries and hold forums on these topics, and it's only going to continue to get richer. We bring the images back into the classroom. Rick will talk much more about this. This happens to be my students. We have an immersive lab, and you can walk up to the hard copy Gigapan, but you can walk up to a digital Gigapan and really zoom in and out. It's really a lovely thing. And then we're looking forward. We haven't tried this yet. This is just a screen capture shot. This is a setup. But we look forward to taking these iPad G3s out in Gigapan Mobile. And if you don't have a soil pit, at least you've got a digital soil pit. And then you've got a vegetation community or a land use around you. And you start making connections. If you don't have a geological cross-section, you have one online, nearby perhaps, or even a distant landscape. Rick, your turn.
Thanks, Ken. What I'd like to do is just talk about using Gigapan in teaching our introductory soil science course at Penn State. And a few points about that. First of all, this is a very large enrollment course. I teach over 300 students each year come through the course from a huge array of backgrounds. And I discover that most of these students have never really gone below a centimeter or two of depth in soil, and they haven't really thought much about soil. And it's a real challenge to reach these students from such a diverse array with very little soils background. And Ken turned me on to Gigapan a couple years ago, and I saw what it could do on landscape images, and we began to think, why not try this on soil profiles and use it in teaching, something we can bring into the lecture hall. Our situation with this course at Penn State is we have one large lecture section of 170, 190 students. They're then broken down into multiple labs units of about 24 students in each one. And we do take 3 field trips each semester with these students. But to maximize the benefit we can get out of these field trips, it would be really helpful for them to have a good understanding of what they are going to see, what they are going to experience. And Gigapixel images, bringing them into the lecture room, really facilitates the field experience. It doesn't substitute for the field experience, but it really helps them to maximize what they can get out of the field experience. And what I'd like to do here is just try to show you a little bit of how I've been using this in the classroom. So here's our Gigapan image of a one soil profile, and what I do is I show students this profile first, and I'll then show them another one. And I don't have time to zoom in and out on these right now, but I mean, all of you know what we can do with gigapixel images. And simply can ask the students who may not think they know much about soil, which of these 2 profiles is going to be more productive, which is going to be better suited for agriculture. What do you think about these 2? And they usually will pick out that, yeah, this Hagerstown soil is going to be much better suited for production than this one, and they may not even realize quite why, but we in fact then can link to the landscape images and look at those and compare the obviously agricultural landscape of the Hagerstown with the Andover soil, which is just a half a mile away but slightly up the slope. And students begin to think about, you know, what is the difference between this soil and this one. And we can start using the previously set up snapshots to start looking at what are some of the key differences in these soils. So we talk about how they were formed in the parent materials, and we can zoom in on this colluvial parent material in the Andover soil. I can flip over to the Hagerstown and zoom in on the limestone parent material, and they get a very, right away, a very good idea of the different parent materials of these soils, how they've influenced the resulting soil. And then we can also go back and look at the whole profile and start talking about what makes this how we put this profile, or how this soil is arranged in horizons, and start to look at some of the detail in it. We can look at our A horizon, the upper horizon, enriched in organic matter, lots of root proliferation, soil aggregates in a granular shape, and then we can go deeper in the, deeper in the horizon, deeper in the profile, and look at soil structural units much deeper in the profile. They can immediately see this is greatly enriched in clay just from the sheen, and they can see the blocky structure instead of granular structure. We can start talking about those types of differences among these different soil profiles. And so when the students actually go out in the field, they know what they are looking at, and we can talk about, point out differences in color and key features that indicate poor drainage in the Andover soil. We can talk about redoxomorphic features and see the differences in color indicating oxidized and reduced conditions in response to changes in moisture. And then students begin to put together what are all the causes and effects for these things. And when we do bring them out into the field, we the students are much better prepared and get a much better experience. This is what it looks like in the lab, or excuse me, in the lecture hall. And what I actually have here is two profiles up side by side, two separate browsers, and can compare two soil profiles side by side. And here we're looking at differences in organic matter accumulation in a forest situation versus the agriculture situation. So just to wrap this up, with Gigapan we can bring multiple landscapes into the lecture hall in a dynamic way. Students can also explore these on their own. We heard earlier this morning about the importance of exploration, and students can do this on their own. And finally, I can't emphasize enough how much this helps to prepare students for going into the field and knowing what they're going to be looking at and what they can see, and greatly enhances their field experience.
Okay, I'm Patrick Drohan. At Penn State, in our department, I teach a lot of the advanced courses for undergraduate students and graduate students that deal with how you describe these features. And at this point, when a student's at the level that I get them at, they're being trained to be a field soil scientist that needs the experience of seeing a lot of soils. Becoming a good soil scientist is like becoming a good musician or a good painter. It takes practice, it takes experience, it takes seeing a lot of soil profiles. And today's students face a lot of challenges in constrained class times, with development around many universities across the country. The time it takes to get out into the field is increased because of traffic jams. Budgets are shrinking. It becomes expensive to start digging a lot of these pits. And landowners start to become a little sensitive to lawsuit risks. So there's a lot of challenges facing us training students. And because there is this need to see a lot of soils to attain this long-term experience, the Gigapan opportunity provides us with another way to extend that training experience. And so what I've been doing in my courses is using the technology as a way to enhance the experience that the students are getting in the field by then linking case studies that we go over in lecture to what they're seeing in the profile. And so you saw the previous examples of how we can hot link to different features within that profile that we see on the Gigapan image and then enhance that experience. They may not have the 4 or 5 hours that you want them to have in that profile in the field. They may have had an hour or 2 hours there. You can now extend that field experience by using some walkthrough case studies that are available on a web-delivered instructional material. The other thing that I've been doing a lot is linking the Gigapan technologies with the other technologies we're using to really enhance the experience even further. Here you have an example of a soil just to the northeast of us here in Allegheny County. The soils in this part of the state are some of the most challenging that we have because of their expansion and contraction when they become wet. There's a mineralogy associated with these soils that is very responsive to water expanding that soil when it enters into that mineralogy, and then when it desiccates down, it shrinks substantially, and this results in a significant landslide risk in this area. Okay, so here you have an example of that soil profile from a nearby farm, and you have on the right there a sample of that profile that's been excavated from it, mounted on a board, and then we can use that as an instructional tool in the building. We have examples of these from soils around the state in our department, hung on walls. But for students now participating in our distance learning at Penn State, they don't have the access to campus and to this collection of what we call soil monoliths. And so what we've been using is the next engine scanning technology to scan these monoliths now, and providing these using a 3D application via Adobe Pro or Adobe Acrobat Extended, where you can actually now zoom in to the scanned monolith using, again, a case study driven exercise where the student will investigate the structure now, and you get more of a tactile experience with that education lesson. So you're getting even closer now to that field experience. Not quite there yet, but you're at the 3D realm. You can see that structure, you can see the color differentiation, so you get a little bit farther. Now, combining that with the Gigapan technology takes you to the even next step even farther once you start bringing in the story in a video perspective. So here we have an example in the upper left of a video I made of one of our former graduate students' family in Pennsylvania. They're Eastern Europeans who settled in Pennsylvania around the turn of the century. They were coal miners. They owned a home over a flooded mine. The flooding pressure in that mine caused the water to come to the surface. Destroyed their property. It looks like the surface of Mars. The mining company bought them out and they had to move away. She lives about 700 yards away now. For her master's degree, she wanted to go back and figure out how to reclaim these landscapes. So there you see us in B sampling the soils with an undergraduate student. C, you see a close-up of this surface after the acid mine drainage, this low pH, iron-rich material surfaced, killing all the vegetation on this site. If we now use other technologies that we have available in our laboratory, like high-end microscopes here on the left, we can actually see these salt efflorescences that come out in the summer when this material desiccates down. So the acid mine drainage, which has a lot of residual sulfate in it in the waters, the sulfate precipitates out with calcium, and we get this gypsum mineralogy that you see. Then we can take these crusts, scan them with the next engine technology, bring this now into even a higher resolution realm using scanning electron microscopy. And so there you see in 2 an example of that salt efflorescence. We can gather data on different aspects of the crust to compare 1 versus 2. Go to 3, which is the scanning electron imagery of that gypsum salt, show actual data that shows the composition elementally of that salt, and then tie that back to other data that we have in our lab in 5 that actually gets at the mineralogy itself, and then bringing it full back to the Gigapan. So you have an intact, tight lesson within that single realm, but linked technologically in a classroom that enhances that overall field experience.
We actually have time for a question or two.
The link that you were describing from your scanning work on and the kind of more quantitative science back to the Gigapan, how are you doing that?
Right now we're doing it through our internet web delivery educational tool called Penn State, like Blackboard. So I have that all built in. And the video movie that we have designed hits several topics that then during the case study that they're reading and they're asking questions to, will say, okay, now go to the Gigapan image. Go to this hot link, discuss what you see and how it relates to the movie. So the soils are the true socio-cultural science. You're sitting here because your food came from the soil, your cotton clothing came from plants that grew in that soil, the oxygen from your breathing came from plants in that soil, the water you're drinking is filtered through the soil. And getting this across to students in a way that they understand that linkage between human behavior and the problems we have in that soil, that was driven by a cultural history of what we've done with that landscape. And so the case studies are a way to take students who may never want to become a pedologist like me, but may want to get into that conservation side, or even some other aspects like glaciology, to look at how these landscapes are affected by people, and the socio-driven nature of those questions really keeps students interested. So that's a great example of where, the human challenge, the persevering, the immigrants, the mining company floods them out, it's got everything in the Hollywood movie there. But then you bring it in, well, what really matters is what you're studying in that landscape, and how can you remediate that? So then you can train the scientists, pose the hypothesis, test the hypothesis. You're constantly doing that in your soil sciences.
Question about how are the students relating to I mean, this is, you used it for what, a couple, 3 years?
Well, really 2 semesters.
2 semesters. What do you sort of, what's the feeling of how the students are reacting to it?
Well, first, generally they are very wowed by the new technology. So they love the idea they can go here and zoom in and out and look at different features and find different features. So it really wakes them up compared to just having a still image up on the screen. I can take a picture of the landscape and show it, I can take a picture of the profile and show it, but the ability to zoom in on the key feature that I'm talking about, and we can explore those and find all kinds of fascinating things. And so that really wakes students up in the lecture, for one thing. The ability to animate and explore it, but the fact that they can go then and realize, oh, I can go and do this, during the lecture, I can sit here and do whatever I want with this image. I don't have to listen to the guy up on the stage, right? So it's been very helpful. I mean, obviously, we still have students that are going to blow it off, but there are some students that are really fascinated by it and really piques their interest, and that ability for them to explore really, I think, is the key part of it. There's so much information in that profile that they could find and relate to things that we're talking about with water movement, with biological activity, with transformations and translocations. It's all there, and they can find evidence of what I'm talking about in almost all aspects of the course.
One more. So while you're thinking of your question, let me just say that I was just told that apparently Twitter is abuzz with news from this conference, and I bet long shots in response to that.
There's more than just me.
All right, excellent. Can't imagine this crowd being Twitterers, but I guess. I was curious just to ask about time-lapse. I'm always interested in this question of time-lapse. Is there a role that can play, or will these cuts, once you expose them, sort of a bad example of something that over time?
I think it's an outstanding example of the original features forming that in a lot of cases will enhance the structures of the soil over time. Another aspect is how water interacts with that surface over the course of the seasonal changes. I do think there's a lot of potential. That organismal movement is really, really interesting.
If there's some setup that happens, so Rip will come in with this trowel and in places draw a shave a quarter inch off the profile, and there will be some fauna that comes out. So that's interesting so it animates the soil. There's pros and cons to it, like I said.
All right, thanks again.